Okay, now we will start. Sorry for the delay. Yeah, today we will have our Cloud Native Night with the title Kill Cloud Build with AI featuring StormForge. Yeah, our schedule for today is, where is it? Here. Yeah, first Alex will told us something about how to reduce your cloud costs. Yeah, and then afterwards, Niels will present his product about yeah, reducing the resource consumption using VPA and HPA. Yeah. So next, for our local guests, here are, if you need a Wi-Fi, scan it, or I think the QR code is also over there. Yes. Next is in about 4 weeks. We will, some of us at Coavia, we will stay, present some talks and workshops at Cloudland. It's a community conference in the Phantasialand in Brühl. Yeah, and if somebody wants to get in, speak to us. We have some discount codes. Yeah, and the next event, also event where we will present are the Kubernetes communities in Munich, and yeah. So I will hand over to Alex.
Okay, thank you, Christian. Then let me really quickly also share my screen so the remotees can see it. Let's see. How does this look like? Perfect. Okay. Then let's start with talk 1. Killing the cloud bill. Yes. The aim of this talk is, of course, making you the perfect Beatrix kiddo that slashes the cloud bill in half. And yeah, let's dive right into it. Who knows what happened on the 1st April of this year? April Fool's is correct, but unfortunately, this wasn't an April Fool. Anyone? No? Okay. Azure significantly raised their prices. Yes, they significantly raised their prices by, some people say 15%, it's like hard to tell. And this was like a really, really bad event, obviously, for a lot of people, and kind of new also because, well, prices have been mostly falling in the cloud prior to that, with a few exceptions from Google here and there. Yeah, and that makes this talk even more relevant today than any other time. And yeah, it was a really bad day also for a lot of our customers, and a sad day, and made my work interesting again, because attention was again on costs, and I like to optimize costs. But the question is, how did we end up here that this is even an issue? Yeah, it's that 11% can really make people sweat. Why do we waste money in the cloud and almost break our bank when the cloud provider raises their prices by 10%? Usually when we start building a software, we start small. Yeah, we build a few instances in the cloud or a small Kubernetes cluster, build the first applications, and cost isn't really a concern there. It's like building the product, and eventually we lose track that there's even a Kubernetes cluster that we sometime provisioned, maybe not on the optimal configuration. And yeah, the configuration drifts over time, and we don't really notice that the small installation that we did doesn't really fit our new workload anymore. And we couldn't have done any better either in the beginning, because in the beginning we didn't even know what we were building. Yeah, so we did a lot of wrong things. I don't know, provisioned to big databases or something, and we figured out much later when this price increase came. And also in a lot of cases, until this date, it didn't really matter to a lot of larger enterprises because they have plenty of money. Some people made a lot of money, especially during COVID, and their cloud bill wasn't like the driver of their business. Like, it wasn't really an issue. It was just that this incident increased the attention on it. And yeah, as I said again, also, usually it was like prices were falling. So even though the usage of cloud increased over the years, especially at AWS, most of the time they announced one price cut after another. And so just by running in the cloud, you were already saving money. So it wasn't really an issue until then. And yeah, and the final reason is why people are wasting money is that, yeah, analyzing your cloud costs is actually really complex, because you have lots of tiny resources that accumulate some cost, like individual IP addresses, inter-VNet traffic that you usually wouldn't think even of, that this could be like a price driver for your system. And you have to look into this. There's a very famous AWS chart, if you want to look it up, how traffic costs can accumulate within the cloud. It's unbelievably complex. Look it up if you want to. So, and that's one reason why also people don't really like spending time with that, because it's like really complex in some cases. Yeah, and that's why we're losing money. It's a complex thing. And well, what can we do? First off, maybe let's ask the internet. There's like always someone who also has the same problem, right? So let's see what the internet says on saving money in the cloud. And of course, the first thing is that you always find is usually by the cloud providers themselves. They say, hey, why don't you switch the pricing model? Yeah, we have reserved instances. If you pay 3 years upfront, then we will give you some discount. Yeah, or we also have spot instances where you just can bet on the current instance, like in an auction, where the leftover instances are, yeah, offered for very low prices. That's also an idea. Unfortunately, both of these things are kind of harmful. I have never seen someone using a reserved instances until now and actually done it right, because most people overspend because they commit, and then afterwards they start to optimize their services and figure out, oh, I shouldn't have reserved so much. And with the spot instances, the issue is you're also losing guarantee that you still have these instances when the cloud gets full. So not really desirable for a lot of workloads, specifically only for batch workloads where you don't really care if this is really relevant. And yeah, the final version also just prepay. Just give AWS, Azure, whatever, I don't know, 1 million in advance, and they will give you a discount, no matter how you use it. That's one of the answers that especially the cloud providers want to present to you, switching pricing models. The other option is autoscaling. Yeah, autoscaling. I haven't seen many systems that really need autoscaling, to be honest. Yeah, but apparently there are. Yeah, okay, that's good. The other option is like do a whole re-architecture of your service to FaaS, container as a service, or some cloud batch service, which is definitely a good idea if you have the time. Yeah, and that's also one of the common answers. Just do everything differently. Then actually a kind of good tip for very, very certain people. If you're in the cloud and you do a lot of traffic, it's usually cheaper to go through the CDN of the cloud provider than just directly to the internet. And it's also at the same time faster, which is nice. This is where people with very, very high traffic volumes can save a little money, but also not really applicable to everyone again. You could, of course, also consider switching regions. Some regions are much more expensive than others, especially the new ones in the Middle East or in some Asian regions. So if you can afford to move your whole application, your whole data center to another region, you could save some money. Apparently, that's also a good tip from the internet. Of course, yeah, shutting off unused things. Yeah, duh, okay, you can do that. Or you can just go back to on-prem. Yeah, that's what the internet says on saving money. And yeah, a lot of these things are to some people very applicable and would help them a lot. I'm not really impressed. Yeah, because as I said, some things are really risky, rarely applicable, and yeah, re-architecting my whole application is like a huge effort that I should have already done when moving to the cloud, right? So not sure if I want to do this every year. And I think we can do better, or at least I think I can do it better, and get you to the Beatrix Kiddo level. And what I want to present you first is how I tackle such an issue. The first thing I usually do is I configure alerts and budgets for the cloud spending, because that's usually the first step. Stop the bleeding. Yeah, if my customer is losing money and he's calling me to reduce his cloud bill, the first thing is I should make sure that it doesn't get any worse than it already is. Then actually deleting unused resources is a really good thing, because larger enterprises usually have a lot of unused resources. But the thing is, the cloud providers also provide you tooling for that. For example, AWS has Trusted Advisor. It will just tell you which resources are heavily underused, and you can then look into it if they are actually underused. And this is like obviously the no-brainer to saving some money. And then the actual work starts. And this is like, if you don't know your Cost Explorer or your, I don't know what's called in Azure at the moment, like the thingy that shows you how you spend your money, you should really get to know it, learn it, and especially learn to group things in different ways, for example, by resource type. And yeah, identify cost drivers in your infrastructure. Then you can sort by percentage. For example, if you're spending a lot of money on S3, yeah, you can prioritize on that. If you're spending a lot of money in storage or compute or traffic or managed service, this is where you can find this out. And then you should just sort this by how much is it of your cloud bill, and think of measures to reduce it. For example, if I'm able to reduce 50% of my egress cost, maybe this will reduce my overall cloud bill by 20%. Yeah, you should define measures and calculate the impact of each of these measures and sort them again how you want to tackle this problem, and execute them from top to bottom until you're happy. And then at the end, if you have done all that and you're at the point where you say, okay, I can't do any more optimizations without really hurting my availability or doing a lot of effort, then you can think about a savings plan, like prepaying some amount of money to AWS or whoever to get some additional discount. That's the order how I would do it. And the issue is most people start at the bottom, reserving some instances, and then look into what they're actually spending, and overcommit for years and lose a lot of money. Yeah, and to my experience, in many cases, you can save around 50% of your cloud bill. I've done this a few times for different customers already. And yeah, you can expect like 50% because we all do this. We build stuff and we don't really care. I did this just recently, honestly. The focus was on building the software, and later on, at some time after 2 years or something, cost was suddenly an issue because of April, for example. Yeah, so that's completely normal, and I guarantee you there's a lot of potential to save money in your infrastructure. Okay, so that's the overall process, and now let's get to the actual stuff. Tips that I kind of think that are always left behind or not given enough attention to, and observations that I did over time. Let's start with the first one. And this is actually the most important one and also the most obvious one, which is right sizing. Yeah, and it's unfortunately also the most time intensive one. What does right sizing mean? Right sizing means that you, first off, have some monitoring. If you don't have it, that's already an issue. But if you do, then look at your resource consumption. For example, here's a Kubernetes cluster where we see, okay, we have only CPU requests around 32% and memory requests around 45%. So obviously, I'm having too much resources in there. I'm not using the VMs that are in my cluster to the full extent that I should. And that is actually a very common view for me. Or a very well-known view that I often see, because most systems actually tend to idle. There are a few exceptions, of course, that are really user-facing, but most of the backend systems, they mostly idle. And this is where you can really save some money. And yeah, how do you tackle this? For example, if you're doing Kubernetes, a solution that we already used a few times before is Goldilocks. And this just helps you in figuring this out quicker, where you are, which workloads are wasting resources, and gives you even recommendations how to downscale them. It's a Kubernetes operator that just looks at your historic Prometheus metrics, and based on this gives you a recommendation. And yeah, that saves you just time, because you have to think less. You just have to apply the recommendation, watch the service fail, and repeat again, look for the next iteration. Because the truth is, of course, you have to, and that's the hard part. I know, do I have a slide for this? Yes. So obviously, you first have to deploy the monitoring. Yes. Deploy the, maybe something like Goldilocks. Yeah. Review the usage, the recommendation that the tool gives you, then apply the new settings, put the system under load if you can, in a reliable way that is fitting to actual production workloads, or deploy it just to prod and pray for the best. Yeah. And then learn that it's not enough, and then readjust to the current settings with new data, and repeat this whole process again. Yes, and of course you can do this more conservatively, where we slowly go down and not immediately start from the bottom, so it's more safe. But this is like an iterative process. I have done this a few times. This takes weeks, months, whatever, to get really right, and to squeeze out the right sizing. But unfortunately, it's the first step for everything else, because you have to have this data, what you actually need to get to the next steps, which we talked about in a second. Yeah. Yes, and also you also have to do this continuously, because your services change. Yeah, you will do code changes that completely change the resource utilization from storage perspective, from memory perspective, from CPU perspective, and so on. So that's really hard, but unfortunately necessary. And by the way, if you're still setting CPU limits, please read this, don't do this anymore. Just a reminder, okay? If you want the link, read it, you can ask me later. Okay, once you have done the right sizing, you can actually start to do some infrastructure changes. And the most obvious one is actually just upgrading your instance type. A lot of people start off with old instances that they have provisioned, like, I don't know, 5 years ago or something. And the cloud providers usually provide newer versions of that, of the same sizing, just newer architectures. And usually these are slightly cheaper, very slightly cheaper, but they are more performance. So you get free performance for just for a little less money, actually. So this is the first thing that is really obvious. This is something that everyone can do. So easy, right? Other option, a lot of people are using Intel instances by default, because they are kind of the default on the different cloud providers. But actually you can get away with AMD instances usually also very well. And you get also a discount, usually around 10% or something. And in many cases, they are actually faster than the Intel variants, depending on your workload, of course. So this is also something you can do. Now, if you're considering switching architectures, of course, there's also ARM instances, which are, again, much cheaper, 15% cheaper, actually. And this now really depends on your workload, what you're doing. If your service can even run on ARM, if you're doing Windows stuff, obviously, this will be hard. Yeah. But if you're doing some interpreted language, or I don't know, Java or Go or whatever, usually this is doable. Yeah, and with some good performance gains in many cases, actually. So that's what you can do. But we're not finished with switching instances, because you did the right sizing, and from my experience, most systems idle. It also makes sense to switch to different ratios of CPU and memory. So by default, most cloud instances and all cloud providers have a CPU to memory ratio from 1 to 4. So 1 CPU, 4 gigabytes memories, and in different sizes. We are obviously a Java shop, so we do a lot of Java. And what do Java services do? They eat RAM. They eat RAM and do nothing. Yeah, and this is the perfect example where you want to go to memory-intensive, memory-optimized instances, which just means they have more memory in relation to CPU. So you can get the right instance that you can't get on-prem maybe, or in the cloud for your workload. And these are, for example, sometimes 30% more expensive, but you only need half of them. So that's a significant saver on costs that you really should consider, especially in non-prod environments. Yeah, where you don't, and maybe it's also the other way around. Maybe you have, I don't know, Node.js. Maybe I don't think Node.js needs a lot of memory, but it's very CPU intensive because it's not well optimized. Then you might go for the CPU intensive workload instances, yeah, where you just need really the CPU. And there's also I/O optimized instances that are more specific to just high I/O workloads and so on. So once you've done the right sizing, you can do the better decision here and actually save a lot of money. So changing instances. And that's about instances. What's the next thing? I think most people forget, especially in the enterprise, when they have a lot of stages like dev, test, QA, and prod, that most of these systems aren't really needed 24 hours a day. Not at all, actually. And at my current customer, actually 3/4 of the clusters are not needed 24 hours days, only during work hours. And if you calculate this, actually you can shut off a lot of resources 70% of the time and only keep them up whenever people in that specific time zone that work on this specific service do really need it. Yeah, the testers, the developers, and so on. And you can, as we are in the cloud, really easy automate this with a scheduled CI job that just deletes the instances. With Kubernetes, it's really easy, reducing autoscaling groups or something like that, and actually save money. Yeah, you can't do this on-prem. You can't throw your hardware out for the night and put it back in the morning. That doesn't really work. And what I think is really important when you do that, because that's obviously the first thing that I usually hear, is you have to obviously allow the out of schedule start. Yeah? If someone's staying longer, yeah, if someone starts earlier or has to fix an incident and needs some place to test it out, you have to really optimize the UX and the speed of getting the system back up. So that's really important, and an important aspect to get acceptance for this solution. Yeah. Cool thing is, some cloud providers actually provide support for this. For example, in Azure, the Azure Kubernetes servers actually has a specific use case for that. There's an API call that you can call, or also you can trigger it to the CLI. Just tell my cluster go to sleep, and yeah, it will reduce all the autoscaling groups to 0 or VM scale sets in Azure, and even disable the control plane so you don't pay anything anymore, which is really nice. And also, let's not almost focus on compute. Of course, the same thing goes with databases. Yeah, here's an example from AWS, of course, but this applies, I think, to almost all the cloud providers with minor exceptions, that you can just shut off databases and only pay for the storage that's that you persisted on disk. Yeah. So this is also where you obviously can save a lot of money if you have a lot of non-prod environments. So that's stage sleeping. Another thing that usually gets forgotten is that you're not only paying for VMs, but also for the disks attached to the VMs. Yeah? And the same thing applies here with the VM instance types. First off, move to the recent version of your storage class. Yeah? So for example, if you're in AWS, and I know a lot of people, I've just talked recently to someone who's still on GP2 for his disk types, it's a no-brainer, or no, it's not really a no-brainer, but you can switch to GP3, get better performance, and save money just by going to the new version. So there's not really a reason not to do it if you have a lot of storage in your cloud infrastructure. Other options, of course, blob storage is tremendously important in the cloud for all kinds of things. And there's also a lot of different storage classes there that you can use. For example, you can use infrequent access when you have data that you don't need that often. You pay less for storing it. You can reduce the availability of it to certain zones with one zone infrequent access, for example, or just declare it as archival storage, so that you really, really rarely access, and even reduce the price even more. And at AWS, there's even the option of enabling intelligent tiering, that they just do this for you. Yeah, they just detect from your usage pattern how your specific file should be treated. So this is also something where you can save money. Yeah, and obviously the same. And one more thing that you can do is actually just avoid using block storage or attachable block storage in the cloud. And AWS, I think it's just defined by size. If you have ephemeral storage, so storage that's part of the hardware under the VM that you get into the VM. So if you have said differently, if you get use a instance type that is large enough, you also get some ephemeral storage in these VMs that you can just use. It will not be persisted, but you can use it for temp files, for unpacking things, and so on. And a lot of people forget that and attach some volumes to these VMs because they think they need volumes, or just increase the operating system disk to much larger amounts because they have to temporarily store some data. And you can actually use just the hardware host disk for this. And in Azure, it's very different because there you have to do a specific decision where you say you want the D in the instance type name, the small d, which means disk full in Azure, where you say, okay, I want this specific instance size, but I also want some part of the host disk that I can use. And this is, I think at AWS, this is definitely free. I think here it is a minor price increase, but it's not comparable to the price that you would pay if you would attach a block storage volume to this disk, to this instance. So much cheaper, and specifically for the people that do Kubernetes, where all the storage is externalized in some database or some block storage in the pod. This is very relevant. You can save some money there. So this is also something that people tend to forget. And then, of course, we're getting to the more obvious things. Being cheaper in dev, yeah, we all do this to some degree, but just as a reminder, you can also do cheaper storage classes there with spinning disks, for example, instead of SSDs, yeah, reducing IOPS. You can use burstable instances for databases. You can reduce SLA options. Specifically, AKS is a popular example for that, where you just pay for the SLA extra in prod, and they say, okay, they will take more care of it if it breaks. Yeah, you can turn this off on dev, and you can reduce availability. For example, your failover instances for your databases, usually not really technically required, even for testing purposes. You can reduce the zones where your blob storage is reduced, which we already talked about in dev. You can reduce replicas, and you can use less availability zones in general. So, for example, there are AWS zones that have, I don't know, 6 availability zones or something. If you just want to make sure that your service works across availability zones, you can just go back to 2, and it will still work, and you will pay less inter-traffic communication. Depending on what you do, this might also save you some cost, but you're still sure it will still work, which is nice. And my final tip, negotiate. There are I know a lot of instances where negotiation with the cloud provider pays off. So they're not really only an API. I mean, I've heard very different stories depending on which cloud provider you're on about their customer support. But at least for some of these providers, they're happy to talk to you and make the cloud work for you and provide you some special offers. And specifically for some capabilities, for example, traffic, there's a potential for huge discounts if you talk to them. So do that once you've optimized everything. Yeah, so I'm nearing the end of my presentation. What's the gist of it? What do you have to do to become a cloud Beatrix kiddo? First off, start at day one. Yeah, it's much easier to do this from day one than later on, and having to explain to your product owner that you wasted a lot of money once you show him the cost-saving potential. Yeah, so just start at day one. Definitely put a focus on monitoring and alerting, and make sure you can actually not only monitor the functionality of your service, but also if it's cost effective. Yeah, so that's a different spin. Yeah, not only if the requests are fulfilled successfully, but also are you using your database instance enough? Yeah, so maybe you could consider also putting some metric on there. Yeah, that you say at some point it says no, you're not. And then make it a habit. Do it regularly. Yeah, review, improve, repeat, and so on. And yeah, that's a lot of work, of course. And as you already all read the title, and we're living in the age of AI, can we get maybe like a robot Beatrix kiddo that does all this repeatedly? That would be nice, right? And with that, I'm ending my presentation and setting the stage for Niels.
Thank you, Alex. I just got the information that we have at least one question in the chat.
Okay.
Is it correct that AWS generates 30% of their revenues via idle?
Maybe, I don't know. You would have to ask them, I guess. I have no idea, to be honest. But if you hear something or know something, please tell me. I would be very interested.
That's a question that I would be also interested in. Are there any questions from here?
Yes.
Hello, do you maybe also have experience with like environment footprint dashboards or something? I mean, that also kind of plays in that use case.
You mean from a climate saving oh, okay.
Yes.
Actually, we are involved in a whole meetup around this topic. There's the Sasha here? No. The green software, someone help me, please. What was the last word? Okay.
Probably foundation.
Yeah, there's, oh, manifest, okay. Yeah, we're part of an organization that actually focuses on that and does specific talks also in the Munich area around this. Yes, definitely. And I think this is a really interesting point. And what I want to emphasize in this direction is actually, you can do a lot by using less. That's one dimension. But I think what really is interesting, we are all in the position of building software systems that other people use, and we can put better options in front of them. So for example, recently, if you know, Google Maps integrates, if you plan a route, it shows you an option which is better for the environment, right? And you all who are building software should think of cases where you can do the same. By the way, just as a little gist more. I think cost saving plays very well with that, but I think it's even more important to change the products that we're all building to help other people do better decisions. And we are in the position of doing this because we can calculate things that other people can't. Yeah. So yes, but it goes even further.
I in the chat mentioned that AWS has an CO2 footprint view in the billing console. And he has also a second question. How can I do real-time cost alerting in AWS?
Real-time, define real-time. Unfortunately, the cloud providers know that their billing or their their cost aggregation algorithms are not very, or that cloud billing is very complex, because they also take like a few hours, I think, in diff to actually calculate your current cost. And unfortunately, you can't get any faster than that. So real time, not sure. I don't think you have an option there unless you do it everything yourself and be faster than the cloud provider. But you can definitely, in the cost view, set some alerts and also some predictive alerting. But yeah, I don't think there's a real-time option if you're talking about minutes or something. Yes?
Wait, just.
Since this is also like cloud-based, what about, I don't know, KubeCost, for example, like as a tool? Does it make sense to use? Or do you see any improvements out of that? Or
yes,
like
definitely.
Tools like that, basically?
Yes, I think there are even better ones, but
like what?
I don't want to spoil the show, but I think there's a real benefit in. So KubeCost, for those who don't know, is specifically in the domain of showing you what a service actually, or a workload on your cluster actually costs. And obviously this is like half the bill. For example, what they don't look at the moment is, for example, the attached volumes or something like that. So that's, and also the use databases, they don't look at that. They don't look at how much S3 you do, or how much traffic you do. So it's a very specific small part of your cloud cost, depending on what you do. Because I have customers that have more storage or more traffic. Yeah, so, but anyways, the good thing about KubeCost and things like that, there are a lot of options that do the same thing, is that they give you a price indication for your specific workload. And this is really good from, I'm primarily a platform engineering at the moment. This is really good from this perspective, because you can actually show that people, you're not only using like one cloud CPU, but you're actually spending that much of money. And that really helps to educate people and to do better decisions. So that's where I see the value of that you actually translate the resource units in your part to money. That's really good.
Okay, Kai joined also our discussion. So what's your question?
Hello together. One more question on my side is, we have a lot in our place, we have a lot of Java, old Java stuff. And everyone told me that it's not so easy to switch to the ARM processors for saving money because of the old Java stuff. Is it possible? Is it a big deal?
I'd say it depends, but I think I know a lot of cases where people have done this and this worked out really well. And specifically, for example, if you're talking about AWS, they have special JREs that are optimized for their ARM CPUs. So they do faster crypto, for example, if you use their JRE. So yeah, should be possible, actually. I don't think, and I would argue that in most cases, this should be doable without too much effort, actually. But it really depends what you're doing. It's hard to predict.
Okay, and the question before was, because I was asking the stuff with the real time. For me, it was more like maybe in 1 or 2 hours that I know the information, because I got a lot of issues in the last time that some colleagues used very much or very intensive the S3 API. And the S3 API, if you do a lot of questions or check out and send, it costs you a lot of money. And so I got an issue where I've had 1 or 2 days later, then a bill more than $2,000 or $3,000 for S3 API calls.
No, so there's a few operators and stuff that like check your deployments and tell you how much money you just spent in a month. There's something like that. But if you're talking about API access or bills that are generated through API access, you have to rely on the cloud services. And even with the S3 access log, I think this is even delayed to up to an hour or something. So even if you do it yourself, you don't get like under an hour, I think.
Yeah,
so
I think, yeah.
It's really hard. Yeah, I don't think, maybe metrics, maybe you can check the metrics, but then you have to be very specific and know what you're looking for.
Yeah, right.
Okay.
Okay.
Thank you.
We have one last question from Ruben.
Okay.
Between Azure and AWS, which cloud is more expensive for containers?
I will not answer this question. No, depends, I guess. If you're doing Windows containers, I'm pretty sure you should go to Azure. But really hard to say if you're looking at total cost of ownership and how much you spend in your development effort to get things running. I would argue for AWS.
Okay, thank you, Alex. And
thanks.
Yeah, Niels, it's your turn.
Yep. Okay, so thank you, Alex, for your talk. That was pretty informative. Also, thank you to the rest of the QA team for having us and setting this up. Really well done. Thank you so much. So my name is Niels Rudet. I work as a solutions architect for StormForge. Alex mentioned we're a solution next to some of the others. That one that you mentioned, obviously, we'll talk about those. And what we do is we help you optimize your resource allocation in Kubernetes environments. This can be on-prem, can be in public cloud, but obviously the impact is going to be the biggest if you do this in the cloud, from a financial perspective, that is. Also, I'm going to talk about VPA and HPA and how they can help you, and then basically what StormForge does to make it even a better experience. So why do we talk about this? Well, it turns out it's fairly complex to set resource allocation in Kubernetes environments and set them correctly. What happens quite often is that developers are left to determine, how much resources should I allocate for my application, and quite often that results in a gamble. Basically, they don't know, so they might just use an Helm chart that has configuration in it, deploy it that way, basically use the defaults. They might have some experience, they might have some ideas how to set it up. And then go with that. But that doesn't necessarily make for a good configuration. And obviously, Alex did a really good job in explaining this, but we see a lot of wasted resources, particularly in public cloud. Then once the applications are handed over to operations teams, they are more or less responsible. And at some point in time, people are going to say, hey, like Alex just mentioned, this application is now running, it's running well, but we need to start saving cost. And then the issue becomes, who is going to be responsible for this? Who is going to come up with better recommendations? And that's where we come in. So request and limits. Who of you actually works with Kubernetes? Okay, quite a few hands. That's good. Hopefully some of the people online as well. Yep, I see some online hands raised, so that's good. So hopefully the pain of setting requests and limits. I saw some people's shocked reaction to Alex's comment that we should not set any limits. That's a whole different debate. We can probably spend the whole evening on that, but definitely an interesting topic. But requests and limits is what you set at the container level, and you can imagine if you are using Kubernetes quite heavily, you might have thousands, if not tens of thousands, of containers. So if you over provision there, let's say you're a developer, you're biased, you think, my workload's going to need at least half a CPU core, maybe 256 megs of memory, or maybe even a gigabyte of memory, and you over provision 1,000 workloads. That's a lot of CPUs that you're potentially not using, but you are definitely paying for. The other thing, if you're using HPA, horizontal pod autoscaler, where you scale out your workloads, you need to come up with a target utilization. So what is the average utilization of resources within my pods? before I scale out to more replicas. That is also a value. How are you going to come up with that value? You don't know, basically. So, and Alex described it really well. There's this process. You run a load test, you measure, and you revisit this over and over and over again to hopefully come up with the correct values. So I mentioned them already, VPA and HPA, vertical pod autoscaler, horizontal pod autoscaler. These can definitely help you. They can more or less automate the process for you, but you still have to set, these values. Also, if you're using VPA and HPA together, they might actually work against each other. If they're both scaling on CPU, one of them is trying to raise the utilization of resources, and the other is actually trying to bring them down to a particular level. So if you set them wrong, they're going to be fighting with each other. So in the land of, well, let's just say unicorns, developers actually know their application really well. They come up with really good values, and nothing is, nothing's wrong. You're not overpaying, you're not over provisioning. But to be fair, that never happens. I was talking to some developers during lunch at KubeCon in Amsterdam a couple of weeks ago. And I asked them, I didn't know these guys at all. They were from the US. And they say, oh, we're developers, we do this all the time. And I was like, what's your process? What does your process look like? And they went like, yeah, we just gamble, then basically double the value and run with it. And if nobody complains, it's all good. And I was like, do you think other people do this the same way? And they were like, that's how everybody does it. I'm not sure if that's true, but they seemed very convinced that this is the way to do it. And I asked them, how could you potentially better? How could you do this differently? And they said, yeah, we should probably load test it, revisit it, test it, tune it. But we don't have time for that. And it's very boring as well. So we don't do that. Well, that kind of gave me the confidence to say this, that nobody does it. I'm really curious if anybody actually does it. Do you revisit your settings? Do you actually tune them? Do you update them? Anybody here? Yeah, that can be a really good reason, right? If your reliability is suffering because you're running out of memory all of the time, that might be a good reason to revisit it. Definitely, yeah. Yeah, sure. Could be, yeah. So it's not only about cost saving though. It's also about making your application more reliable. Like was just said, if your application constantly runs out of memory, that's definitely a bad place to be. Unless you set it too low and double the too low value, but there's always the chance of having it wrong, right? So yeah, that's definitely a problem. Like I said, in reality, it doesn't work like that. We don't see a lot of people actually testing it, revisiting it, because also, even if you get it to like a reasonable good value, if the usage of your application changes, and hopefully your application's usage is quite dynamic, then you're never going to get it right, basically. So it's pretty hard to do. I think it's a fairly similar process to what Alex has described. Is basically you analyze your application's requirements, you come up with a value, and you set a baseline. Then you can conduct load tests if you want to. You can monitor the response of the application, tune the values for your resources, and hopefully the application still runs well, runs reliable. And then you can keep coming up with different iterations until you find like the best value that you can. But this is a lot of work. And quite often, the people that need to do this are either your developers or your experienced Kubernetes people that you probably want to have spent time on different projects. Now, if you don't use autoscaling and just come up with a really high value, what you end up with is a lot of waste. So if you look at the white line on the left, that's the actual usage of resources in your environment. Then the orange line is the request that was set, and everything in between is basically waste. Now, waste sounds like a dirty word, but it's also very pricey because you're paying for these resources. On the other, basically, extreme end is where people under-provision their workloads. And what you then end up with is unreliable applications. You run out of memory, you get CPU throttling, and that's obviously not a place where you want to be either. It's more or less a coincidence that Alex just mentioned this as well, but there is better ways of doing it. You can obviously utilize the VPA, you can use the HPA, but you still have to come up with these values. If you use something like Goldilocks, you can automate some of it, but you still have to apply these settings yourself. You have to revisit it. You make sure that these recommendations are good. This is a bit flashy. One thing to note is that most people will start with HPA because it's less intrusive to your environment. So if your workload utilization is going up, you just add more pods to it if your application is capable of doing so. But then you have to focus on the target utilization. So at what point, at what utilization level of your pods, on average across your pods, you want to add another replica. That's a pretty hard value to come up with as well. So quite often people will just gamble, see if it works, and might over-provision quite heavily. The thing with autoscaling, with horizontal pod autoscaling, is if you have your resources set too high, so you're over-provisioned by default, and you're then scaling out, you're multiplying this waste. So like it shows here, you still have a lot of wasted resources when you're horizontal scaling. So you were kind of expecting this probably, but StormForge has a product called Optimize Live. And what we do is we measure the actual usage of your resources. So for per container, we measure the actual settings of the requests and limits. We measure the actual usage of consumption. We feed this to the machine learning, and the machine learning comes up with a recommendation. This recommendation, you can set the, let's call it aggressiveness, or the risk that you're willing to take. You can set it to, I think we now call it cost savings. That sounds better, right? So if you want optimal cost savings, which would have been aggressive previously, the recommendation is going to be pretty close to the actual usage of the resources. If you set it to medium, it's going to be a bit more headroom, a bit more padding. If you set it to optimal performance, there's going to be even more padding. The cool thing is, it doesn't matter if you have 1,000 pods, 10,000 pods, or even hundreds of thousands of pods. The machine learning will come up with recommendations for all of them on your set frequency. You can come up with recommendations every hour if you want to. You can set it to once a day or twice a day, once a week, depending on the how dynamic your environment is. And the cool thing is we also directly show you the impact. So we show you, this is your current settings, this is your current usage. If you were to apply the recommendations that we come up with, this is the impact from a resource perspective. And we also add a financial to that. The way it works, basically you install one agent. We call it very originally the StormForge agent. It consists of 2 containers. What it will do is once you have it installed on your cluster, so you install one agent per cluster, it will automatically go out and discover all your workloads, depending on if you let it, because you can obviously restrict it to specific namespaces, or you can just tell it to only look in specific namespaces. And then it will find out all your workloads. We support deployment, daemon sets, replica sets, and it will present them to you right away. So in the UI, you will see all the workloads, and it will, after 1 hour of scraping metrics, performance information, it will start coming up with these recommendations, and you will see them right away in the UI. Sorry. These recommendations are for both CPU and memory. We can set requests and limits, but we can also combine that with a optimal setting for HPA target utilization. Then you can decide if you want to automatically or manually apply these, or if you want to export them to a YAML file, so you can run them through your CI/CD pipeline. This is obviously a continuous process, so you will always have up-to-date recommendations. In the UI, you will right away see a top 5 of clusters that, and this is obviously unreadable. I'll try to show you in a live screen in a minute, but we will show you which clusters would have the biggest impact if you were to apply the recommendations that we come up with. We also show the top 5 workloads that have that would have the highest impact from an over-provisioning perspective. And we also show you the top 5 workloads that are under-provisioned, because you can obviously be over-provisioned, but you can also be under-provisioned. If you were then to optimize these settings, your performance should be way better. Any questions before I show it?
If there are recommendations, somebody still needs to go and type them.
What do you mean, type them? To apply them. So actually, we can apply them automatically for you.
You mean on the cluster directly?
Yes. We can also set them to manual, where you press a button in the UI to apply them. If you, for instance, have the system come up with a recommendation once a week and you want to first verify it, if it makes sense to you, then you can manually apply them. Or you can export them to a YAML file where you basically just run them through your GitOps repository or something like that.
Okay, thank you.
Sure. Hopefully this is readable. I just wanted to show you really quickly what the agent looks like. It's a really small footprint. So I have this cluster running, and if I go to the namespaces, you'll see that this is StormForge -system namespace. And if I do a get pods, there's basically two pods running. I have installed the agent. That's the first one that actually will go out and gather the metrics and come up with, send these metrics to our machine learning and then come up with the recommendations. And then the applier is an optional component. If you want to be able to automatically apply the recommendations, that component is also needed. So once you have the agent installed, like I said, it will go out, go to the namespaces that you allow it to, and discover all the workloads on your cluster. And then the recommendation, well, first the gathering of metrics starts, and it's obviously the actual usage of resources per container. Also the current set requests, current set limits, if there are any, and that is then led to the machine learning. The result is something like this, like the screenshot you just saw. And as you can see, there's the workload name. So there's different workloads in your cluster, obviously. There can be multiple clusters. In this case, there's one cluster. And which namespaces there are, what type it is. Most of them are going to be deployments. And then something we call efficiency. What you'll see is that the efficiency is a combination of CPU and memory efficiency, where the CPU is heavier from a efficiency perspective, because it's a more expensive resource. Then what you can also see is the current total requests. We call it total request because if the workload is consisting of multiple replicas, it's a combined value there. The current resources, so the current number of cores, the current number of memory, and then also the what the cost of this combination is. Then write to it with optimization. So if you were to apply the recommendation that we came up with, and in this case, it's a special one. As you can see, it's red, which means that this was actually an under-provisioned workload. So if we were to apply recommendations, the resources would go up. So yeah, it's about cost savings, but in this case, it would be more expensive if you apply the recommendation, but your performance will be better, obviously, because currently it's under-provisioned. If I go to one of the workloads that I have configured earlier, here you are looking at a summary for this specific workload. And as you can see, the overall efficiency is 63%. This is something that will go up over time, because this one is set up to automatically apply recommendations that we come up with. It started off with something like 35% efficiency, and it's now slowly going up. But what you can see is that the impact, if we were to apply the latest recommendation, was 147 millicores would be taken away, 10 megas of memory, 10 megabytes that is, and the cost savings would be $3.42 per month. Now this is really small, obviously, because recommendations have already been applied. But we have customers. Actually, one of our customers is the biggest customer of AWS EKS in the world. They have hundreds of thousands of these workloads. So if you're saving a couple of dollars per workload, that adds up quite dramatically. And they are saving millions by using this kind of technology. So here you can see once the recommendation is generated, and this one is set to come up with a recommendation every hour, you can just press the apply now button and it would go out and patch the deployment. You can export the patch, download it as a YAML file. Obviously from a UI, it doesn't make a lot of sense if you have that many workloads. So you can do it through the API, you can do it through the CLI as well. The top graph here shows you the total CPU usage and requests. Here there was a restart. But if I turn off the impact and the current total request, we show you the total usage of resources and the recommended total requests for CPU, that is. So as you can see, since it is set to be quite aggressive, actually I'll show you how it's configured, but it is set to be quite aggressive and recommendations every hour, that the settings actually follow the actual usage pattern. Now this can only be done if you're okay with setting these values every hour, obviously, which in the current version of Kubernetes is going to result in restarting the pod, because otherwise it can't be applied. So you need to have an application that can actually work with this. So we have 3 different tabs here. So if I go to recommendation details, you can see that we can select a specific container, because if your workload consists of multiple containers, you might want to be able to see that per container. And here you see it for this specific workload. As you can see that the requests and the limits follow the same pattern more or less. There's just a bit of headroom in between them. If we then look at the configuration for this particular workload, how I set it up. I set it up to do recommendations every hour, like I said, and then to automatically deploy them over here. The CPU optimization goal is set to savings, which I called aggressive, because it's going to be pretty close. The recommendation is going to be pretty close to the actual usage of resources. And if you get it wrong with CPU, you get CPU throttling. Obviously, it's not something you want, but it's not going to kill the application. For memory, it's set to balanced, which means there's going to be a bit more headroom. There's going to be a bit more padding on top of it to make sure we don't run out of memory. By default, it's set to come up with recommendations once a day. Obviously, the automatic deployment is turned off and both are set to balanced. If you then go to configuration details, something not a lot of customers actually should need to visit because it's set up quite correctly. The default is to optimize requests and limits for both CPU and memory. But if you want, you can give the machine learning boundaries to work within. So if you know there's like a minimum value you don't want to go beyond or below, you can set that up for both the request and the limit. And you can also decide on the padding between the two. So if you want to go for quality of service, for instance, you can set the limits and requests to be the same. Or you can also decide to go with a custom value. Currently, the dollar amount is not configurable, or the value of CPU and memory. The next iteration will be out in a couple of days, where you can actually set these values yourself. Because, like it says here on purpose, this is based on a Google instance that not a lot of customers actually use, just to make sure that it is an indication. But yeah, we knew we were going to add this functionality where you can just select different kinds of images. Let's see. Yeah, I think that's it, what I wanted to show, because otherwise it's way too much detail. This was already a lot of detail. Any questions on what we do and how we do it? There's somebody there.
Okay, thanks.
There you go.
First question, easy question. Do you guys also scale yourselves? Do you scale your own agent?
We can, yeah.
Very cool. Okay, second question. The machine learning algorithm, does it have different kinds of classes of workloads, or are they basically all treated the same, estimated the same?
For Optimized Live, the idea was to make it as simple as possible, and they're all treated the same, more or less.
Okay, thanks. And third question, when you have recommendations that are hourly versus ones that are weekly, are they still going to be the same, or are they different?
No, they're definitely different. As you can imagine, if you set it to once a week, you need to make sure that you're taking in considerations the peaks and values that you've witnessed over the past 2 weeks. Once we've gathered 2 weeks of information, we base our recommendations on these 2 weeks. If you've had some really high peaks and you're basically deciding on a recommendation during a low usage of resources, you might be out of resources for a big part of that week if you only change the recommendation once a week. So it definitely changes the recommendation and the way it's set, basically. Yeah.
Okay, thanks.
And that's why I also say that if it's once an hour, it's going to be more aggressive than if it's once a week. More questions?
I have a question. And before I ask a question, I actually have to clarify something I said earlier, because I said I rarely see systems that require autoscaling. What I meant to say is that I rarely see systems that could make use of autoscaling, because horizontal autoscaling, because most where I see our customers lose a lot of money is in non-prod environments, and they just run the same replicas with the same sizing as in prod to make absolutely sure that they're doing the same thing, and autoscaling there would make nothing, and at least horizontal. And I think vertical is much more important, as you already showed, because I'm making my problem worse when I do horizontal scaling.
Yeah.
And I think so I really wonder, because we already when we optimized the resource consumption also for the non-prod environments, this already took a lot of time. And I wonder how much, is there a big gap between what I can save in non-prod environments with your solution?
Versus production.
Again?
Versus production, you mean?
Yes.
I mean, the cost is the same, right? So a resource in dev or a resource in prod is usually the same. It's CPU.
Yeah, but do you have some experience data from,
okay,
you will save more in prod or more in dev? Or?
Yeah, so what we definitely see is that in non-production environments, there tend to be lots of copies of applications running, multiple instances for test purposes, different teams working on it. And the usage is obviously going to be really low, unless they're stress testing it or load testing it. But quite often that is not the case. So the savings, although initially we said this is for production, and what we meant with production was actually live applications, but we definitely see a lot of savings in non-production environments, for sure, yeah.
But they will then most likely be more static than in prod?
Yes.
Okay.
For sure.
Okay,
yeah.
That's what I want.
Yeah, no,
cool.
Definitely.
Yeah, we also got a question from the chat, and the question is, can you go under once an hour, e.g. every 10 minutes?
I mean, technically we could, but we have not, talked to customers that are willing to update the settings, more than once an hour. Once an hour is actually quite aggressive already, depending on your application, how it's built, whether or not, it's capable of restarting fast enough to do these things. So yeah, technically we definitely could, but yeah, we haven't had any requests in that direction. What we see, to be fair, is that most of our customers apply recommendations once a day or once a week.
Okay. Other questions? Yeah.
The data and the machine learning computing is done on your infrastructure?
That's correct. Yeah. So we recently moved to a more SaaS-like environment where we take the metrics from the cluster, ship them to our machine learning, which is running in the public cloud as well. Yeah. We are planning on, so currently that's in the US based. We are planning a European based instance as well, which is most likely going to be in Germany. But still, yeah, we run it in cloud ourselves.
But there's no plan to allow self-hosting the computing?
No. That's, to be fair, that's a fairly common question, specifically from financials, you know, some specific industries as well. We have put a lot of effort in building something like that, but it's very hard to maintain. So we decided against it, basically. Yeah.
Thanks.
Sure. To be very specific about it, because people are always going to ask about security. You know, which kind of data are you collecting? What data are you moving to the cloud? It's only metrics information. So we gather the workload names, we gather the namespace names, just so that we can show them in the UI to present it for humans to be able to read it. And besides that, it's only current settings from a request and limit perspective and the actual usage. That's what we collect. So there shouldn't be any IP or identifiable data in it, unless you name, you know, your namespaces after your kids and social security number or something like that. But hopefully you don't do that.
Okay, some other questions.
I think that was it.
Yeah, I think that was it.
Thank you.
So, yes, thank you, Niels, for your coming. Thank you to all, remote attendees, and yeah, we'll say goodbye to all remote attendees, and for all here, grab some beer, grab some drinks, some food. There's something there, and yeah, thank you for coming.
Thank you as well. Bye.